All right, guys, I'm Nicolette, and today Brian and I are here with Matt Gerber. He is the CEO of Rohinni. We're going to talk to him about LEDs today. So thank you so much for joining us, Matt. We appreciate it. How are you?
I'm doing great, Nicolette. Thanks for having me on the show.
Absolutely. So just to kick us off, why don't you tell us a little bit about yourself and your journey to Rohinni and what's going on over there with LEDs?
Yeah, so be happy to do that. So I'm a double E electrical engineer by education, and by some practice. They took my screwdrivers away a long time ago. And what I really like doing, what I enjoy more than anything else, is to help grow things. And whether it's growing a high performance team, or it's growing a product line, or growing a company. And so I've been involved for a long time with tech startups and early stage technology companies. I had met the founders, or the founder of Rohinni, back in 2008 when he was looking for board members for his prior startup. And we had a really positive experience with that company. And he called me in 2013 and said, "Hey, we're putting the band back together here. I'm looking for another board member. Are you willing?" And so I joined the Rohinni board in 2013 and stepped into the CEO role in 2016 when the board felt the technology was at a point where we needed to seriously look at commercializing it.
So how are you guys bringing LED technology to the consumer?
Well, we like to describe ourselves as we make the impossible products possible when it comes to lighting and lighting products. And when our founder saw back then what was called a mini LED or micro LED, because they weren't as well defined back in 2013, and we can talk about that in a bit, but he looked at that and he said, wow, I could take this small little unpackaged semiconductor, and if I can figure out a way to place a lot of them at a very high rate of speed, very accurately, I can create really, really amazing lighting products. And that was the concept that gelled in his head, and he founded Rohinni based on that thought.
So I was going to get into this a little down the road, but maybe we should stop there and talk about micro LED, mini LED versus a regular LED, and kind of just break down what the difference is.
Perfect. So the good old fashioned LED, we talk about these things like they're dinosaurs now, right? Mm-hmm. The good old fashioned LED is a piece of semiconductor, and generally it's a little larger than what you'd see people calling mini, and a lot larger than what people call micro LEDs. So let's just say it's a piece of semiconductor that's a millimeter square. And the most important distinction is it's put in a package. So that device is placed in a carrier, and there's some secondary processes that are used to attach an anode and a cathode to it. So when you see a good old fashioned LED, you see those things that look like little bulbs, or you see these square plastic carriers that have the actual LED chip in them. And so those things, when you look at them compared to a mini LED or a micro LED, the first thing you noticed is there's no package in a mini or a micro LED. So you've eliminated all of this size and weight and space associated with the packaging. So that's one big difference. And then the second big difference is the actual semiconductor, the actual chip that's in there, is smaller. And it took a while after we got into the space before the industry kind of recognizes the difference between mini and micro. And so right now, when you look at definitions, I think generally accepted definitions of a mini LED is an unpackaged LED, a flip chip style, which means the anode and the cathode, the conductors are on one surface. And they're anywhere from 50 microns square to, let's say, 300 to 400 microns square in the XY dimension. And you'll also find those on a substrate. So they're also tall compared to a micro LED, because the substrate that the active LED layer is on is generally 80 to 100 microns thick. So picture a cube that's maybe 200 microns by 200 microns by 100 microns. That's a mini LED. And then when you get below 50 microns, you're getting into what people are calling these days micro LEDs. And so they're significantly smaller, but the biggest distinction we see between minis and micros is to get that small a chip, you have to strip off the active layer, the epitaxial layer from the substrate, because you can envision a chip that's got an XY dimension of 5 microns. It can't be 100 microns tall because you almost have a straw, right? Like structure, and you can't do anything with that because it's highly unstable. So in the micro LED world, the epitaxial or active layer is stripped off. So you have something that may be 5 microns square by 3 or 4 microns thick. So you can actually place it and use it. So those are the differences.
So do you see, is there, okay, so between the full size LEDs, the micro and the mini, is there a difference in the amount of lumens or the amount of power they're using to produce the amount of lumens?
So it's one of those engineering answers, right? It depends.
Okay.
Which we all hate, right?
Yeah.
So the cool thing about what you can do with micros and minis now is you can put a lot more of them in the same space that you would use with a packaged LED.
Mhm.
And LEDs are like a lot of semiconductor devices where you have to, the harder you drive them, the more energy you waste, right? So if you have an LED light bulb, you can feel it heating up. If you have LED lights on your car and you put your hand on the surface, you could feel heat. The really cool thing about the products that we can build with minis and micros is you put so many more LEDs in the same space that you don't have to drive them as hard. And in not having to drive them as hard, you get the same light output, but you don't waste any energy. So as an example, one of our customers, that's a big notebook brand, did a keyboard backlight, which is one of the applications we focus on. And they built the keyboard backlight with mini LEDs as compared to a standard LED driven backlight. And they saw a power reduction of 93%.
Wow. And
Wow.
especially on something like a laptop where
Wow.
you're very concerned about power
It's-
consumption and battery life and things like that.
Well, that's
Yeah.
actually that was actually what I was going to ask you. How did the different options then change the application for the potential of of your applications then?
So there's kind of 2 big buckets of potential. And one of them we call sort of the run of the mill stuff that gets people interested but not really excited. And then there's the really exciting bucket of stuff. And the run of the mill stuff is some of what we just talked about, which is reduction in size, weight, and power. So if I'm building an application, let's say I'm building a display backlight, I can put 10,000 emitters, 10,000 mini LEDs in a 75-inch TV, high performance mini LED backlit TV. And I can create a backlight that's significantly thinner. It's less weight, and it uses a lot less power to drive the same amount of light through the LCD display, right? So that in and of itself gets you a thinner TV, gets you better picture, lot of great benefits. But for us, it's sort of incremental.
Right.
When you get into the wow stuff, and this is some of the stuff we talk about with like our partner Magna, it's a big automotive company that we have a joint venture with. If you can envision a vehicle of the future that's autonomous, where you or I were riding in the back of this fully autonomous vehicle, it doesn't need normal headlights, it doesn't need normal taillights. What it needs to do is communicate with its environment, because other people may be driving their cars while you're in this autonomous thing, or it pulls up to a stop sign and you're waiting there at the crosswalk wondering, is this thing aware of my presence?
Right.
And the way the Magna Rohinni automotive people think these vehicles are going to communicate with their surroundings is via light. And because you can take a lot more of these mini and micro devices and use them to animate with light. Can you imagine if you have the front of that vehicle with millions of these LEDs, it essentially turns into a display. So the ability to turn any surface into a display or into something that can emit light and animate that light, because you have so many emitters, it basically works like a display. That's when people look at the tech and go, wow, this is game changing. Because, if I could use this stuff like wallpaper,
Mhm.
It's the future, right? The movies you see where people are sitting in rooms and the scenes
Right, and
are all
everything's
Oh,
changing.
I could use some of that wallpaper. That sounds fun, actually.
yeah. So it's pretty cool stuff from both the incremental benefits and then the long-term game-changing stuff we see.
So you mentioned like automotive. Where else do you see it in the future? Either in the near future or the far future being used.
So when it comes to LEDs, there's a couple of different paths, right? And I think this is relevant to the folks that are listening here. We focused on LEDs and lighting applications, but don't forget what we do allows you to use any kind of micron scale semiconductor. So if you want to build a sensor field that you embed in the front door to a house, right? So you can visualize who's standing outside your door, or
Right.
you want to be in front of a video wall and have it really track accurately to your motion. You do that with micron scale semiconductors and you build a sensor field. But let's stick with LEDs. The applications really are limitless in terms of what you'd want to do, because you now have the ability to create light and animation in spaces that you couldn't do it in previously. And so it's everything. When you look at where we as a company have started, we started with the basics. A lot of us are ex notebook people. And so we said, okay, we can build a better backlight to start with, right? So that's where we started. And then we moved on to, and our Lumi joint ventures in production now, if you buy certain brands of gaming notebooks and you see the logos on the lid and how they animate and they do all kinds of color changes, that's the next application area we moved to. And then automotive was the third, and then high performance displays, video walls, and those sorts of things were the fourth. And probably the next big move for us is going to be when we feel the time is right to get into core lighting applications, and probably starting with architectural lights, right? You can imagine if you go to our website, rohinni.com, you see we hold up this thing we call light paper, and it literally looks like paper that you can light up, and you can put that on any surface theoretically.
Do you think some of it's going to play into, we talked about these cars lighting up and, whatever wallpaper changing. Do you think some of it's going to play an effect in like sort of virtual reality?
100%, because what I just described to you, where when you're at a point where you can surround yourself with display technology that is it's high performance, it's absolutely real. Like you look at what micro and mini LEDs can do for displays in and of themselves, right? Brighter, higher resolution. So you get these super, super bright, high res displays, and then you embed sensor fields in them, the ability to interact with these things without having the VR gloves and the goggles.
Exactly.
No, it's getting very close to that. I think the next 3 to 5 years, you're going to start to see those kinds of applications.
What needs to change? I mean, or improve, I should say, to get there,
It's a great question. And I think the thing when people are looking at mini and micro LEDs that they need to realize is that they're very different technologies and they have very different challenges associated with commercializing them today. And when you look at minis, the nice thing about minis, so those are the bigger ones, 200 micron-ish square, 100 micron square on the substrate. The nice thing about products using those technologies is the supply chains are pretty much established for mini LEDs. So there's no new process technology that needs to be invented at the LED suppliers. We perfected the placement technology for these things. The end of line processes are all in place. So you're going to see mini LED based products, whether they're keyboard backlights or logos or displays, you're going to start to see them proliferate in the next 12 to 24 months, because it's really just ramping and figuring out optimization of production processes. The next leap is going to be micro LEDs. And that's where a lot of people don't realize there are major problems that need to be solved for micro LEDs to be commercialized. And it's everything from up at the start of the supply chain with LED manufacturers coming up with production processes for the raw micro LEDs that produce those things reliably, because it's a different process to take an LED wafer, cut it that small, strip off the active layer, and then sort those so that a manufacturer can build with them. That doesn't exist at scale today. Then the way to place those things, right? A lot of people are spending a ton of money in the venture world trying to figure out how to take those micro LEDs and place them reliably with a high yield rate in massive volumes. That's not perfected yet. And then there are others, rework and some other production related processes that still need to be figured out before we see true volume micro LED based products. And my own opinion, our opinion as a company is we're probably going to see in the next 3 to 5 years some, call them point level or niche kind of applications, very small displays, very premium products, but it's going to be 5 to 10 years before we start to see any kind of mass market adoption of micro LED based products.
So what do you think engineers really need to look at in terms of designing in these mini LEDs, right? What are the things, or especially coming up, that they should be thinking about when they're designing their products now that may be released in the next few years?
Yeah, so I would break that down in a couple of different things I need to be thinking about. One is at the very highest level in terms of problem solving, is if you're building a product and it requires using light, then doing it with a different paradigm, right? Because now I don't have to deal with the constraints of packaged LEDs and the limits those things impose on me. And I could use a lot more of these devices and put them in a given space. So a good example to give you, and I know it's kind of a mundane sort of an application, but a keyboard backlight, if you put a big packaged LED under each keycap, even if it's red, green, and blue, you're fairly limited in the type of animation you could do. But now if you can take under each keycap and put 10 LEDs or 12 LEDs, you could really start doing some things that allow that user to interact with that keyboard in a different way in terms of animating the keyboard and changing colors and personal preferences. And that's sort of the most basic application where you don't have a lot of LEDs. But a car designer, as an example, you almost need to think about, if you're going to build a taillight, then from a functional perspective, I've got so many LEDs in a taillight, I could display almost any kind of information in that tail lamp. So fundamentally thinking differently about the thing you can do with the product and the value you can offer a consumer is the highest level thinking. And then I think the next level down, it's if you're solving problems of size, weight, power, like a great example, taillight. We all know these taillights, if you see a car taillight, they're pretty big, heavy, bulky assemblies. They got a lot of depth to them. Well, if you wanted to build a really lightweight car, you could build a taillight and make it 100 microns thick, right? And you don't need that size, and you don't need that power level. So there are some basic engineering trades, once you get past the whole functionality trade, some basic engineering trades that engineers should be aware of when they're looking at using these mini LEDs.
What about cost? What about from a cost perspective? Are these, are they going to change things?
Great question. And I think it's partly related to what we talked about before with the difference between mini and micro. So like any new technology, it generally comes out, it's more expensive than the old one, right? And so the new technologies that hook are the ones that offer these fundamental benefits that somebody says, okay, in a high-end product, I'm going to start there. I really want a super thin display that's super bright and very power efficient. And so we're at the very start of that journey right now. So the products we're seeing come out from mini LEDs are in the premium segment. And our own view is that as the LED manufacturers ramp up in their supply chains with mini LED capabilities, and not a big change for them. They just need to make that change. And then companies, the big brands, start adopting in their premium products, mini LED based products in volume. We're going to see the same thing we see with everything in the technology world, right? Whether it's memory or radios, the price is going to come down the curve. And our view is in the next 3 to 5 years, we're going to see price parity for probably 50 to 70% of the applications out there.
Okay. Yeah, that was on my mind, okay, they're smaller, they can do more, do they cost more? But eventually, no. Eventually, no.
Exactly. We think they're going to follow same kind of behavior where, the high end, if you can afford a $3,000 TV, it'll have a mini LED LCD display if it's not OLED. And then 5 years from now, only the low end stuff will have what's currently being marketed in general today.
Brian, did you have a question? Because I have a fun question.
Okay, go for it.
So I want to look back through history for a second. Now, I want to see, what do you think have been the most important changes in the LED industry over, I don't know, since the beginning of the light bulb? Is that too far back? No,
well, now you're asking me to go 100 and something years back.
All right, since
the LEDs,
the past 50, 40 years.
Yeah, so I'll fess up. I'm not an LED expert, right? When you look at our expertise, it's in and around how you take these micron scale semiconductors and you place them at a very high rate of speed, very accurately. What I can tell you is from our exposure to the industry, obviously colors and the range of colors has been big, right? And even wavelengths like UV applications and IR infrared applications or LEDs, those create some interesting product opportunities. But I do think it's what we're talking about now. Since the invention of the LEDs themselves and the benefits of the lower cost and longevity, this is the biggest discontinuity or disruption we're going to see. It's because LEDs started to be able to use them, you needed a package, right? You need to put that semiconductor in something. And this is the first time we have the opportunity to say, okay, I can ditch the package and these things are so much smaller. So I do think this is the biggest discontinuity since we've seen LEDs launched. My own humble opinion.
Well, then, okay, so now we're down to micro. We're down to micro. How much smaller can we get them in the future? Where do we go from here? Disappearing.
It's a great question. And that is one of those technology challenges we talked about, because as a semiconductor device, one of the interesting dynamics you see is there is a point where efficiency degrades if you get too small.
Right.
And so what we're seeing right now is there's a very strong interest in building products like video wall modules or direct emission displays for things like notebooks and tablets with LEDs that range in the 30 to 50 micron kind of size. And those would be true micros, no substrate, epitaxial layer only. Those are pretty big if you want to build a device like a watch or a phone. You need to be down in the 3 to 5 micron square kind of range. And so when you're talking about a pixel, you're going to have a red, a green, and a blue LED in that 3 to 5 micron range. So there are challenges associated with that around efficiency. How much power do you need to drive? What's your trade-off? There are challenges around that associated with testing, because the way, if you're familiar with the way LEDs are manufactured now, when that wafer is produced and it goes to be processed and diced or sliced up into individual LEDs, there's a technology and set of machines that do what's called a probing operation on them, and they probe them to see whether they work or not, and what type of performance they give. Because in any given semiconductor production, you're going to have a range of performance on the chips that come off a single wafer, and they do what's called binning. They put them in different performance bins.
Right.
When you get below 50 microns, you can't probe and test because they're just too small.
Mhm.
And what that means is, as an engineer, if you're going to build a display for a phone and it's going to have several million pixels on it, and you're going to have several million devices, and you can't test any of those, then you're going to have to design in redundancy. You're going to have to design in knowing that a certain percentage of those LEDs you're going to put on that substrate are not going to work. And so it brings between the efficiency problems and the inability to test and the size associated with that, it's a whole host of issues that still has to be solved for.
So it sounds like we need new testing equipment to me. That's really
Well,
what
eventually,
that sounds
right?
like.
Eventually, you get to that
Right.
point.
And it goes back to my comments earlier about, you got to look at minis and micros differently in terms of how easy or hard it's going to be to adopt those things. Because in that micro world, there's a whole host of fundamental technology problems all along the production process and manufacturing process have to be solved. And I'm not saying they won't be solved, because there are a lot of really smart people working on them, but it's going to take time to work through them and solve them.
Very interesting. I think that's the most in-depth discussion we've ever had about LEDs here. I
Love it.
feel like I learned a lot there for a second. And Matt, you did look forward 3 to 5 years, but what I'd love to leave the audience with is 2021. What is there anything happening in this upcoming year that engineers should be thinking of when it comes to micro, mini LEDs in general?
Absolutely. This is the year we will see big brands launch volume products. And so as an engineer, if you're in and around this space, you need to be aware of these technologies and aware of the two different types of benefits we talked about, right? If you have this fundamental change in the size and nature of how this device operates, it can enable a completely different design approach. And this is not theoretical anymore, right? When the biggest consumer brand in the world launches a product or two or three, and you're in the space, your designer is going to come to you and say, hey, why can't we do this? So you need an awareness of that. And as a result, you need to start looking at the realistic performance envelopes of these devices and how do you get them designed in? So this is the year, and anybody who's in and around the space should be educating themselves on what they can do with these kinds of devices.
Brian, did you want to ask Matt anything else before
No,
we
I think
wrapped up?
it was great, Matt. Matt, where can they find more about you and Rohinni?
So go to our website, rohinni.com, ROHINNI.com, and you get a sense of what we do and those impossible products we make possible.
And we will keep you guys updated as well as new stuff comes out of Rohinni. They'll send it on over and we'll share. So thank you so much again for joining us, Matt. We really, really appreciate it.
Thanks, Nicolette. Thanks, Brian. Thanks for having me.